Ever stop to think about uh, the hidden sounds of technology?
Mm.
Maybe for some of you, it's the ghost of that dial-up modem noise.
Huh. Yeah, that sound definitely sticks with you. Or maybe for others, it's just silence.
Right. But the fascinating thing is that algorithms, the very heart of AI, they actually unfold over time. They have their own rhythms.
Exactly. And it's those rhythms, that sort of underlying timing, that might hold a key to how we can really understand AI better, not just as these like black
We're
boxes.
talking about dynamic processes, things with patterns.
Processes.
And that brings us to what we're diving into today. We're exploring how we can grasp AI not as some unknowable thing, but by getting familiar with what the scholar Shintaro Miyazaki calls algorithmic practices.
Yeah, he proposes this really interesting approach called algorithmics. It mixes things like history, aesthetics, ethics, even utopianism and fantasy, believe it or not.
Wow, okay. That's quite a mix.
It is. But the aim is to help us see AI differently.
So our mission today, really drawing from Miyazaki's work, is to unpack this idea he has of encountering AI. And notice that hyphen he uses.
Right, it's important. It suggests both experiencing AI, just encountering it, but also actively countering it, pushing back when necessary.
So it's about empowering you, the listener, to be more informed, more engaged in this whole AI era.
Precisely. And Miyazaki actually starts us off with a maybe surprising historical comparison, Walter Benjamin's description of a chess automaton from way back in 1940.
A chess automaton. Okay, tell me more.
Well, Benjamin described this amazing chess-playing puppet, looked like it could beat anyone.
Like an early AI.
Kind of. But the trick, as people like Edgar Allan Poe later figured out, wasn't the puppet itself. There was supposedly a person, a dwarf, hidden inside actually making the moves.
Okay, so Benjamin used this as an analogy, right? The puppet is like the visible stuff, what we see happening.
Exactly, the surface level. But the real driver, the thing ensuring victory, was this hidden dwarf, which Benjamin connected to theology, actually, the hidden power.
Interesting. So how does Miyazaki connect this old analogy to AI today?
Well, for Miyazaki, the key takeaway is that this hidden dwarf, these hidden mechanisms, they need to be made visible, especially now.
Why now specifically?
He argues that critical thinking, combined with aesthetics and ethics, needs to uncover these hidden dynamics, particularly within what he terms AI capitalism. He sees it as a modern form of potentially problematic power structures.
So the hidden dwarf represents the underlying power dynamics in today's AI systems, the biases, the control mechanisms.
You got it. And Miyazaki's idea of encountering AI is a way to try and bring those hidden forces out into the open, to critically engage with them.
So it's not just accepting AI, it's actively questioning it, pushing back sometimes.
Exactly. It's about understanding those inner workings, so maybe we can transform that dwarf, that hidden power, from just being a tool of control into something more accountable, maybe. Empowered in a different way.
Okay, that makes sense. And this leads us right into Miyazaki's core concept, algorithmics. It's not just about the code itself, is it?
No, not just the static code. It's really about how that code plays out over time, how it creates patterns and rhythms as it executes.
So algorithmics is the study of algorithms in action, focusing on their temporal dimension, their unfolding.
Precisely. How they are programmed, yes, but crucially, how they operate step by step, creating these specific timings, these rhythms. You can think of it as the pulse of the algorithm.
Like finding the heartbeat of the machine.
Kind of, yeah. And Miyazaki connects this to Henri Lefebvre's concept of rhythm analysis. Lefebvre mostly looked at cities, the rhythms of urban life.
Right.
Miyazaki takes that lens and applies it to the digital realm. How do digital rhythms like data flow interact with our physical world, our infrastructure, our daily lives?
That's a really interesting extension, and critique seems central here too. It's not just about observing these rhythms.
Definitely not just observing. Miyazaki draws heavily on Michel Foucault's idea of critique,
Which is,
which is seeing critique as this ongoing attitude of questioning limits, questioning the boundaries set for us, and importantly, experimenting with ways to go beyond them.
so encountering AI is a form of that critique.
Yes. It involves refusing certain kinds of control or governance that AI might impose. It's about opening up space for other possibilities, maybe more inclusive ones.
And he brings in other ideas too, like media archaeology.
Right. From people like Wolfgang Ernst. Media archaeology helps dig into the material history, the actual physical structures, and the discourses that shape how these systems govern us.
Okay. And Donna Haraway's symbiosis. What's that about?
So, if media archaeology looks at the how and why of the present structures, and genealogy helps trace alternatives, symbiosis, which Haraway defines as making with or doing it together, emphasizes collaboration.
Collaboration in what sense?
In the sense of creating better futures together, Miyazaki sees this collaborative world making as a vital part of encountering AI. It's not a solitary critique.
And he gives the example of the video game Never Alone.
Yes, that's a fantastic example. It was developed through a genuine partnership between Alaska Native storytellers and game developers.
Okay.
By weaving together indigenous knowledge and game design, they created something really unique and culturally powerful. It challenges typical game narratives. That's a symbiosis in action.
Very cool. Okay, so we have this theoretical background, algorithmics, encountering, critique, symbiosis. Now let's get into Miyazaki's concrete algorithmic practices. The first one sounds amazing, listening to machinic algorithms.
It really is fascinating. You have to think back to the really early days of computing, those giant room-filling machines.
All with tubes and relays.
Exactly. Some of those electromechanical and early electronic computers, well, sometimes engineers would actually hook up voltage signals from the machine to speakers.
No way. So you could literally hear the computer thinking.
In a very real sense, yes. Miyazaki mentions the IBM ASCC machines at the University of Manchester. He even points to a specific machine at the Phillips Physics Lab that had built-in speakers.
What could you hear?
Apparently, visitors could hear it checking if a number was prime. The rhythm of the clicks and sounds would change depending on how hard the calculation was. It was this direct translation transduction, Miyazaki calls it, from electronic signals to sound.
That's incredible. A direct line into the algorithm's rhythm. Did it help them, like, debug?
Maybe indirectly. It offered a different way to sense the machine's state, but honestly, as operating systems got more sophisticated and automatic error detection came in, the need for humans to listen like that kind of faded.
The machine started monitoring themselves.
Right. But looking back at that practice gives us this fundamental insight. Algorithms have a temporal, rhythmic dimension that can sometimes be made perceptible.
Now, this isn't just history, right? People are doing this today.
Absolutely. Miyazaki highlights contemporary artists and researchers' names like Christina Kubish, Martin House, Valentina Vuksic, and himself included, who are using things like induction loops.
Induction loops, like for hearing aids.
Similar principle, yeah. They use them, along with amplifiers, to pick up the faint electromagnetic fields that all our digital devices emit. Phones, laptops, routers.
So they're making the invisible electronic noise audible.
Pretty much. You can start to hear the different timing patterns, the signaling characteristics of Wi-Fi, Bluetooth. Miyazaki even mentions this specific dactylic rhythm, like a long, short beat that older GSM phones used to make.
Wow. So you're hearing the protocols, the data moving.
Essentially, yeah, it's a way to perceive these hidden temporal layers of our digital world.
That's wild. And he also mentions just programming sound directly.
Right. Using software tools like Super Collider or Pure Data, you can actually write code that translates algorithmic processes directly into sound. So you're intentionally designing an auditory representation of the algorithm.
Okay, so that's practice one, listening. What's the second algorithmic practice?
This one is about being sensitive to rhythmicity, especially when things go wrong, like in network breakdowns.
Okay.
The big one Miyazaki uses is the AT&T network crash back in 1990. Huge disruption. For about 9 hours, their long-distance network across North America was seriously messed up.
9 hours? What happened?
It boiled down to a single, tiny programming mistake in a software update for their switching computers.
A tiny mistake took down the phone network. How did rhythm play into it?
Well, the flaw was in something called a do-while loop, coded in C. It didn't cause problems immediately, but then one switch in New York had a minor hiccup and restarted.
Okay.
When it restarted, it sent out a faulty message during its routing update because of that flawed loop. And that message triggered the same flaw in the switches it connected to.
Oh, like a domino effect.
Exactly, but a rhythmic one. Each affected switch would crash, try to restart, send out the bad message again, causing its neighbors to crash. It created this cascading rhythmic feedback loop of shutdowns across the network.
Wow. So a small rhythmic error in the code, dormant most of the time, suddenly caused this massive rhythmic collapse.
Precisely. It shows how critical these underlying operational rhythms are, even if they're usually invisible. And Miyazaki links this to current research on algorithmic governance.
Algorithmic governance.
Yeah, scholars like Claudio Coletta and Rob Kitchen look at things like smart traffic light systems. SCATs is an example. These systems adjust light timings based on real-time traffic flow.
So the algorithm is creating the rhythm of the city's traffic.
In a way, yes. It's actively shaping urban rhythms through its own operational rhythm. So being attuned to these patterns, both normal and abnormal, is key.
Got it. Okay. Practice 3. Pinging listening as extraction. Sounds more active.
It is. Think about sonar on a submarine. Send out a ping, listen for the echo.
Or pinging a server on a network?
Exactly. Check connectivity, see how long it takes to respond. Miyazaki's pinging listening uses that idea for algorithms. You actively probe the system, send specific inputs, and then carefully listen to or observe the output to try and figure out something about its internal workings.
Like poking the black box to see how it reacts.
Okay. Kind of, yeah. It's an active inquiry. But Miyazaki adds a note of caution. You need to be mindful about what you're probing and why. Ethically mindful.
Okay. And how does this connect to AI filters, like in CNNs?
He suggests thinking about convolutional neural networks, maybe a bit playfully, as these complex machines full of filters.
Filters that process data.
Right. So the idea is, what if you feed different kinds of signals into the network, maybe even sound signals, and then analyze how the network changes or filters that sound?
Trying to hear what the AI does to the sound.
Exactly. It's a kind of audification or oralization, like using the AI itself as a weird audio effect box to understand how it processes information. You ping it with sound and listen to the filtered result.
That's a really creative way to investigate. Does it work visually too?
Yeah, he mentions work by Fabian Offer on visualizing the filters in visual AI, trying to see what the AI is actually looking for, which can help uncover biases, for instance.
But this kind of work sounds complex.
Oh, definitely. Miyazaki stresses that these methods often need people from different fields, computer science, art, critical theory working together. It's interdisciplinary.
Okay, so wrapping these practices together,
Yeah.
encountering AI through listening, analyzing breakdowns, pinging, it's all about making these hidden algorithmic processes more tangible, visible, audible.
That's the core idea, critically examining how AI works, how it sorts, filters, decides. And listening in all these varied forms is really the crucial first step.
Why the first step? What comes next?
Because once you start to perceive and understand these operations, once you gather that knowledge, you can move towards what Miyazaki calls the symbiosis of counter-algorithm.
Back to simply, this is the making together, creating counter-algorithms.
Yes, using the understanding gained from listening and analysis to collaboratively design and build alternative algorithms, ones that might be more equitable, more just, more aligned with the futures we actually want.
So it connects back to Benjamin again.
In spirit, yes. Miyazaki echoes Benjamin's call for a political use of technology. He envisions critical AI and counter-algorithmics as ways to highlight marginalized processes, challenge dominant systems, and build something better.
Like Benjamin saw potential in film and photography to reveal unseen realities.
Exactly. It's about harnessing the technology itself for critical ends.
So final thought for you listening. As you go about your day, interacting with all these digital systems, maybe pause and wonder, what are the hidden rhythms here? What might we learn if we could find new ways to, well, listen in?
Because it's in that kind of active, critical engagement, that listening, that we might find the keys to shaping a better technological future. Definitely check out Shintaro Miyazaki's work if this sparked your interest, and maybe explore related areas like media archaeology and rhythm analysis too. Lots to think about there.